Hello everyone, this is Teacher Chen from Kangaroo Study. Today we are going to talk about question from last year's Spring Cup. This is a geometry question. Let's read question together. As shown in the figure below, the angle ABC and angle ADC are two right angles in the quadrilateral ABCD. If AD is equal to DC, BD is 6 and AC is 8, find the area of the triangle ABC. First of all, let's mark what we know in the diagram. We know AD is equal to DC. BD is 6 and AC is 8. We want to know the area of the triangle ABC. The first thing come to our mind is to use the base times the height. However, we don't know the side AB or BC. We only know its hypotenuse. If we use the hypotenuse as the base and then draw a height, can we find the length of the height? It's hard to get it. It seems that this method does not work. Can you think of another way to solve this question? What's the character of this question? We know AD is equal to DC, and these two sides have the same vertex. What does it remind you of? Rotation. The key point to this question is that if you see equal length sides with common vertex, you should think of rotation. Then which triangle should we rotate? The triangle ABD or the triangle BDC? Either is okay. Let's use ABD as an example, and you can try the other one by yourself. We rotate the triangle ABD anti-clockwise until AD overlap with CD. And then we get a shape like this. Let's keep the mark we made before. What can we get from rotation? Remember, rotation doesn't change the size of any angle or side length. Then we can get that DE is equal to BD, which is equal to 6. And the angle ADB is equal to angle CDE. What can we derive from this? Let's look at angle at vertex D. The angle ADC is 90 degrees. The angle ADB is equal to angle CDE. Then what is the angle BDE? It should also be 90 degrees. Now we know that the angle BDE is 90 degrees. BD is equal to DE. It seems that the triangle BDE is an isosceles right triangle. But is it? To be a triangle, the point BCD have to be on a straight line. Are they on a straight line? To prove that on a straight line, we need to prove that the angle BCD plus angle DCE is equal to 180. How to prove it? What do we know about these two angles? From rotation, we know that the angle DCE is equal to the angle DAB. Is the angle DAB plus angle DCB equal to 180? Let's look at the quadrilateral ABCD. In this quadrilateral, the angle ABC and angle ADC are both 90 degrees. Then the sum of the rest two angles should be 180 degrees. Thus, we prove that the angle BCD plus angle DCE is 180 degrees. BCE are on a straight line. The triangle BDE is an isosceles right triangle. Then what can we get? We can get its area, because we know its side BD and DE are both 6. Then its area is just equal to 6 times 6 divided by 2, which is 18 square cm. What can we get from this? From rotation, we know that the area of the triangle DCE is equal to the area of the triangle DAB. Then the area of the quadrilateral ABCD should be equal to the triangle BDE, which is 18 square cm. Now we know the area of the quadrilateral ABCD. To find the area of ABC, we only need to minus the area of ADC. How to find the area of the triangle ADC? We know that the triangle ADC is an isosceles right triangle, and we know the length of its hypotenuse, which is 8 cm. How to find its area? Let me introduce you a quick way. Let's use AC as the base and then draw the height. we can see that this big triangle is actually divided into two isosceles right triangles. Then the height should be equal to half of the hypotenuse, which is 4 cm. So the area of this triangle is just equal to 8 times 4 divided by 2, which is 16 square cm. The last step we need to do is to use the area of ABCD minus the area of triangle ACD. 18 minus 16 is 2 square cm. The answer to this question is 2 square cm. Now let's take a summary of this question. The main takeaway from this question is that if you see equal length side with common vertex, you should think of rotation. And we need to remember that rotation doesn't change the size of angle or any side length. That's all for today. Do you find the question interesting? Sign up for the Spring Cup. There are more interesting and challenging questions waiting for you. Thank you for listening and see you next time.